So here you got the interview that you can read entirely in the link above, and for one of the questions, he replies, "That's quite an interesting question. The basic answer is no. I can't play in 125 BPMs and 143 BPMs at the same time. Although it's not impossible, it's just a question of polyrhythmic mathematics." Ta-da! Polyrhythmics and Mathematics. So the question could be, what polyrhythms are involved behind these combinations? So for the question, he mentioned 5 examples that we are going to analyze in a different way. We're going to go from the easier to the most difficult. We're going to divide our study in 2 phases. The key point is finding an equivalence between speed combinations and polyrhythms. For the first phase, we're going to start from a speed combination and we're going to get the polyrhythm involved. And in the second phase, we are going to create our own polyrhythm based on a speed combination. For the first part, speed combination to polyrhythm, what we're going to have is a mixture of tempos, and we're going to get the polyrhythm involved behind these 2 tempos. What we do is calculate the highest common denominator. In this case, it's 25. So I divide each of them in 25. So we obtain a polyrhythm of 4 versus 3. For the second case, 125 BPMs versus 75 BPMs, I do the same procedure. And we have the same common denominator. In this case, 25 as well. And we obtain a polyrhythm of 5 versus 3. For the Z example, 100 BPMs versus 66.6 periodical BPMs. These are peculiar because they are relatively primes between each other, and the second one is a periodic number. So what we do is convert the decimal into a fraction, and we obtained 609th. So what we do is amplifying these both. But what number? The least number who make them integers. So if we see the fraction, here the denominator is 9. Hence, the easiest number to multiply them in order to make them integers is 9. So if we multiply 100 times 9, we obtain 900. If we do the same with the second, we obtain 600. Which means after 9 minutes, the first click will have hit 9 times, the second 600 times. This leaves us 900 600th, obtaining a polyrhythm of 5 versus 6. For the example D, we have a periodic number as well, and 75 BPMs. We know what to do. We convert it into a fraction, and we multiply for the least number that make them both integers numbers. Okay? So we obtain 675 and 600. Now what we do is look for the highest common denominator between these 2, 75. So I divide them both in 75, obtaining 9/8. So we have a polyrhythm of 9 versus 8. Now the second step is creating our own polyrhythm. So I'll suggest a method based on a table that I will show you now for you to create your own polyrhythm and have a lot of fun. So in this table, you see 3 columns in which have notes, a number associated, and the number of groups by 100 BPMs. So we have from 8th notes until 9 triplets. Okay? And we assigned a number, 2, 3, 4, 5, 6, 7, 8, and 9. So what we do is dividing 100 in each of these numbers, obtaining these numbers. So this is the table we are going to base our creation to make polyrhythms. So if we want to do a 9 against 5, I took my table. 9 corresponds to 11.1 periodical and 5 to 20. We multiply both for the same number and we're going to obtain a pair of BPMs. And that we can work and develop our independence. So for example, if we multiply both times 50, we'll get 155.5 periodical BPMs and 1000 BPM. If I do times 6, I obtain 66.6 and 120 BPMs respectively. A bit weird. We're gonna try a tempo that we can really count in a metronome, that we can set. Okay, for example, let's check the fraction notation for both. For 9, I got 109th, and for 5, I have 105th. So we looked for the highest common denominator between 9 and 5. In this case, is 45. So I amplify these fractions times 45. For the first, I will get 500. For the second, 900. So we have at the end 900, 500th. So we can speak about 90 50th. So now we got a sort of bit more normal beat. So which means 90 BPMs versus 50 BPMs gives us a polyrhythm of 9 versus 5. Hence, we can apply with every multiple of these numbers, obtaining the same polyrhythm. Then another example, 7 against 5. We look at the table again. I got this for 5 and this for 7. Remember that it's better work with fractions than decimals. So I convert them both in integers, multiplying for a number that make them both an integers. So in this case is 7, based on this denominator. So for the first I get 140, for the second 100. So it means that 140 BPMs versus 100 BPMs will be a 7 versus 5, which could be the same for their divisors and multiples. So back to the first example, 143 versus 125. What do we have? The situation here is this number is divisible by 11 and 13, which leads us the question, what are these notes? We can call them 11 tuplets and 13 tuplets. So it means that I could play 143 in groups of 11 or 13 notes. But then again, how do I combine this with 125? So what we do is look the least common multiple, and for this I do this table, dividing each number in these primes, divisors. So what we can do is either playing 13 groups of 11 tuplets versus 5 groups of quintuplets, or 11 groups of 13 tuplets versus 5 groups of quintuplets. That's why Gavin said it's just a question of polyrhythmic mathematics.